In this chapter, we're going to be looking at solving different types of equations and different types of inequalities. In this section, we'll be looking at just solving basic equations. We're going to be looking at solving algebraic equations, which for the most part are all the equations you've dealt with up to this point in this class and prior classes. We are also needing to talk about solutions, zeros, roots, and x-intercepts. Basically, your zeros are when you set your function equal to 0 and solve it. Your roots are your solutions to that, so roots and zeros are pretty much the same. Your solutions to your equation, or your function when it's set equal to 0, is also another name. Graphically speaking, it's where your graph crosses the x-axis. Now, if the directions say to solve, that means you're trying to find all the solutions to that equation, not just some of them. Now, sometimes when you're solving equation, you'll end up with a answer that you got from doing it correctly, but it doesn't work in the original problem. Those are called extraneous roots or extraneous solutions. Typically, that happens if you have to square both sides or if you're dealing with a rational equation. Rational meaning where you have fractions on each side. So let's go ahead and just look at solving this basic equation. We're going to eliminate the parentheses, so we're going to distribute our 6 through. Here we'll distribute through the negative 3. So now we want to go ahead and try to solve this. So we're going to collect our like terms. We have our y's, 12y minus 3y. Then this gives us a 33. But you know, in trying to solve it for y, you want to get the constant, the positive 33, moved to the other side. So we subtract 33. Now you want to get rid of the 9. And you get 33 over 9 negative, but that reduces down to 11 over 3. Negative 11 over 3 does not, or is not represented well as a decimal because it goes on forever. We are not going to want to approximate that, so therefore we'll leave it as an exact answer in fraction form. If you use the repeating bar for a decimal, it could be written that way, but it's nicer as a fraction. Well, this is referred to as a rational equation. It's an equation because we have our equal sign. It's rational because we have variables also in the bottom of our fractions. Now, just like with rational expressions, you needed to find your LCD to be able to add and subtract fractions together. We want to find our LCD here. So you want to factor each denominator. Take a 3 out of the first one. Our 6 is really 2 times 3. Remember, your LCD is all the different things that are occurring in the bottom, which happens to be our 2 from the 6, our 3 from the 6, and also from our first factor or term, and then also the x minus 3 that shows up. Notice we don't have a choice in exponents in any of these. This is our LCD. Now, since we're dealing with an equation instead of an expression like we were in the first chapter, with the equations, you can do the same thing to each side and still have it be equal. Well, we're going to multiply both sides of our LCD, and our LCD is really this over 1. I'm talking about putting it over 1 because it may help you when you're trying to multiply. So you're going to multiply the first fraction by that. And if it's really over 1, remember in multiplying fractions, you'd multiply the top, multiply the 1 times the bottom. It's not going to change it. Do the same thing here. Multiply it by your whole LCD. Here you multiply it by your LCD. You'll notice then we have some stuff that will simplify. Your x minus 3 drops top and bottom because it's an x minus 3 times the whole top and the whole bottom, and your 3's drop. Here your x minus 3's drop. Here your 2 and your 3 drop. So if you are multiplying by the correct LCD, all your denominators will drop out. So when you look at what you're left here, you're just left with a negative 5 times a 2. Here you're left with only the 4 times the 2 times the 3. Here you're left only with the 5 times our parentheses. So on the left-hand side, We get our 24 and our negative 10. That's where the 14 comes from. Distribute through on the right-hand side, and then continue to solve it for x. And then you end up getting x to be 29 over 5, which could be accurately represented as a nice decimal of 5.8. We're not looking for an approximated answer, but since this fraction is represented nice as a decimal, either one would be acceptable. The only thing we have to double check here is, since we started out with variables in our denominator, and we know we can never divide by 0, will our answer here actually cause us to do divide by 0 in our original problem? Well, our 5.8 minus 3 is not 0. And really, that same thing is in the bottom of the first one. It's just all multiplied by 3. And our 5 minus 8, or 5.8 minus 3 is not 0. So we don't have to be concerned about dividing by 0. So this answer does work. Well, once again, you want to find your LCD. It's really a 5 over 5, or 1, and a 5 over 1, and then your 6 over your 2x minus, or plus 11. The only denominator you have other than 1 is your 2x plus 11. That does not factor, so your LCD is your 2x plus 11. So you want to multiply each fraction up here by the 2x plus 11, which is really, once again, 2x plus 11 over 1, which when you multiply fractions, you multiply the top and the bottom. So it's really just applying the 2x plus 11 just to the top for each one here. So once again, these here will drop out. All your denominators drop out, so here you're just left with a 6. Here you're left with your 5 times your parentheses. Here you're left with your 5 times your parentheses. Distribute through your 5 to your parentheses on each side. We get this. You subtract the 10x from each side, subtract the 55 from both sides, you get 6 to be equal to 0, which is a false statement. You have no variables left. It's a false statement, so therefore there is no solution because we got a false statement. So there are no numbers that make that a true statement. Here, once again, you'd want to go ahead and find your LCD. So you'd want to have each denominator factored. So we have that factored right here, pulling a 3 out of that second parenthesis. So your LCD then is all the different things that occur in the bottoms, which would be our 3, and then we also have our 5x plus 2 showing up. That's your LCD. You multiply each fraction on each side by that LCD of the 3 and the 5x plus 2. Well, then you'll notice you have a 5x plus 2 top and bottom. They're going to drop. 5x plus 2 and your 3's are going to drop. And then you'll have that over there. Now, notice in addition to your 5x plus 2's, your 3's drop there. So then when you look at what's left, here you're only left with a 12. Here you're only left with a 12. And here you're timesing by 0, so that's 0. So you end up getting, in this case, 0 equals 0. Now here you're going to have you have a true statement, so that means all real numbers work, with one exception, and that would be the negative 2 over 5. You might be wondering why? Because that's what causes your initial denominator to be 0. And remember, you can never go ahead and divide by 0. So if you take that initial denominator, solve it for 0 by subtracting your 2, dividing by your 5, that's where that negative 2 over 5 comes from, and that's what we can never have in the bottom. So we're going to be able to use all real numbers except that.